Hello and Happy New Year. Welcome back to the Potential Difference Regenerative Acceleration Motor series. I guess in 2014 we will be focusing our attention on motorizing the regenerative acceleration generator using a pulse DC motorized switch, and right now I'm just collecting some data here on the performance of the motor, and what I'll be doing is changing the configuration of the ReGen-X motor, and I'm just collecting some initial performance data, because what I'll be doing is reducing the air gap. The air gap right now between the rotor and the coils is approximately, well, it's at least half an inch. So I want to bring that down to a quarter of an inch or even less than that, and see what kind of ReGen-X motor generator action that we would get with a reduced air gap. And right now the ReGen-X motor employs pulse DC, but it also employs a flyback switch, such that when the motor coil shuts off, the output, the collapsing motor magnetic field is collected back to the batteries, and we are able to recharge batteries while operating in motor mode. So right now we are operating with a speed of 138 RPM. We're putting 45 volts, 46 volts into our motor coils. We have 3 motor coils operating right now, and we're putting 0.5 amps of DC current into the motor coils, and from our flyback switch that's in our motor control circuit, we are delivering 0.76, 0.77 amps back to our 6 batteries, and we are recharging the batteries. Now I have 6 batteries, and the actual main problem with the flyback switch is that it charges the batteries too quickly. So I keep adding extra batteries in an attempt to slow down the recharging of the batteries, because I'm tending to overcharge them. But nevertheless, for the sake of data collection, we'll just have a look at the performance at various speeds, and then I'll come back and redo the same test at with different setup on the coils. So 139 RPM, 140 RPM, we're at 0.5 amps to our motor coils, with 0.7 coming back. Let's take it up to 500 RPM. there at a 600 RPM. We're putting 96 volts into our 3 motor coils at 1 amp, and our flyback circuit is delivering 2.3 amps to the batteries, and the batteries are charging like crazy. Okay, well, I'm going to stop it there, and guess I'm going to get more batteries for the next test. We'll be right back. Cheers for now. Okay, welcome back. 4 batteries hooked up, and I guess if there's a problem with this ReGen-X motor and flyback, is that it generates too much current back to the batteries. Right now we're putting in a total of 1.58, 1.59 amps to our motor circuit, and we're collecting back 1.6 amps and charging our batteries, and we're also putting in from the batteries 1.1 amps to our universal motor. So let's see. Okay. So we're putting a total of 0.7 amps of current into our motor coils, and 1.2 amps into our universal motor. So, and we're putting back 1.5 amps back into our batteries. Okay, let's try it at 600 RPM and see what happens. Right there. 1 amp at 85 volts going to our ReGen-X motor, 645 RPM. The batteries are charging, albeit slowly. We're putting 2.7, almost 2.8 amps back into our 6 batteries, and we are putting from the batteries to the universal motor. We're putting 0.6 amps of current into the universal motor, and 1 amp into the motor coils, and we're getting back 2.7 into our batteries, and our battery batteries are charging. Let's take it up to 800 RPM maybe. 9 amps going back to our batteries. Batteries are charging slowly. And 0.5 8 amps to our universal motor. Welcome back. Right now what I've done is I've reconfigured one of the ReGen-X coils. I'm running the ReGen-X motor with 100 volts of input and 1.9 amps, 770 RPM. Right now we're putting back 5.1 amps from our flyback into our battery, charging our 6 batteries in motor mode, and we're putting in 0.58 amps to our universal motor, 5.8 amps at DC. So about 0.6 to our universal motor, 1.9 to our ReGen-X motor, 5.2 amps back to our batteries. Okay, we'll be right back. I'll reconfigure the third coil and we'll see what we end up with. Cheers for now. Welcome back to the final parts of this demo series, just performance confirmation. What I've done now again is I've reconfigured the third and final ReGen-X coil in the prototype. I'm running all three coils in the prototype as motor coils. Right now we are putting 1.1 amps into our pulse DC motor, ReGen-X motor, and we are putting 0.7 amps into our universal motor from the 6 batteries that we have here. We're at 385 RPM, and we are returning 2.3 amps back to our batteries, and charging our batteries while in motor operation. I think it's important to note that again that we are operating in motor mode. This is we haven't even incorporated regenerative acceleration into this demo yet. So we're operating in motor mode. We are collecting the discharging magnetic field that's produced around each motor coil. When the switch in the motor circuit switches off, we are redirecting the magnetic field energy that's produced around each coil as it's collapsing, and we are feeding it back into our batteries and sending 2.3 amps back into our batteries, recharging our batteries in motor mode while we are putting in a total of 1.1 plus 0.69. And the grand total that's going into the entire motor circuit is 2. Sure we can get that here. 2.1 amps plus 0.7, so about 2.8 amps total going into the entire motor operation right now, the dual motor operation, with 2.3 amps to almost 2.4 amps coming back to our batteries. So I'm going to take it up to where we were before, with about 100 volts going into our ReGen-X motor, and we will see how much current is going in and how much current is being returned back to the batteries. So here we go. Our circuit is designed for 100 volts. Putting in 2.4 amps into our ReGen-X coils, 0.4 amps into our universal motor, and we are collecting 6.5 amps back into our batteries and recharging our batteries while in motor Cheers. Welcome back. The next stage of development for the ReGen-X motor is to reduce the air gap, which sits at about almost slightly more than half an inch, and I wouldn't be surprised with that reduced air gap to see 10 amps of recharge going back to the batteries while in motor mode, and that's a problem right now with the batteries that I have, because I'm kind of filling up the lab with well, I guess battery acid fumes, because the batteries are charging so rapidly. And so what I'll be doing in the next prototype development, is reducing the air gap and connecting the batteries in parallel. Right now they're connected in series, and I want to check to make sure that the flyback works with the batteries connected in parallel. So stay tuned for that. Cheers and Happy New Year. Bye for now.